let me describe our technology stack for you. We're a microservices-based architecture. All microservices are Dockerized, orchestrated by Kubernetes. So we started
Google's
at
favorite.
1.0, and now we're at
a couple of versions ahead, 1.14, I think.
okay, and using Mongo as the backend, and React, Redux in the front.
So you're using the best of Google, I see.
We're trying.
Yeah.
And one of the things that are intriguing to me is how can we make our architecture, a little bit more serverless. So after you do your thing, I need a few minutes of
So
consulting.
first, you're already in a good direction. I think that if we're talking about serverless services, so Google is making a huge headway. Kubernetes is one step in that direction. I think Knative is the next step in that direction. Google has been GA with its managed Kubernetes offering, and we're releasing a lot of added features as of late. Click to deploy Istio, which I'm sure you're already using. You told me backstage before.
Right.
And machine learning is the second thing where we're making a lot of headway. Thank you.
Good luck.
Okay, so as David said, my name is Yarkoni. I'm a solution architect with Google. In the past year and a half, I've been working with large customers here in Israel, mostly under ML solutions and architecture, how to bring their systems into production in a scalable, reliable way with the least amount of time. And I think that one thing that is key here is time. Okay, we're always talking about Google, how you as a customer can have the best time to insight, and that means from the point that you bring in the data into the system to the point that you're actually using it and gaining insights, how fast is it? How fast are you bringing value to your customers? That's what we're about. So why AI now? And I don't think I'm actually, this is new to anybody, but as of recent, it's been really easy to aggregate a lot of data. It's both easy to collect it, easy to store it, and cost efficient. There are a lot of nice APIs, some of which I will discuss, and I will also discuss some of the tools that Google offers. As you know, Google does a lot of AI, a lot of machine learning. We have thousands of models over the years. You're all familiar with the search engine, but we have over 7 products with over 1 billion users, and many, if not all of those, are backed by 1 or more machine learning models. We've been seeing a boom as of late. Machine learning papers are being released very, very quickly, over 90 papers a day, some of which I'm sure will be discussed in the rest of this convention. Some stuff that you might not be aware of, cool stuff that Alphabet and Google are doing with machine learning. So one of them is the self-driving car, Waymo, which has been making huge strides and headway. Another thing we've been helping, like how machines can grasp and objects, predicting the products of molecules, and those are kind of things which are part of the research, but we're not releasing them obviously as products. So I just want to mention that it's not only limited to the products. TensorFlow. I won't discuss why to use TensorFlow. I will discuss some of the nice things that have recently been released in TensorFlow 2.0, which I do recommend you go and check out. It's booming. It's the #1 deep learning framework on GitHub in terms of stars. And if you are doing it, it's recently been revamped into TensorFlow 2.0. We've really cleaned up the API. We've listened to the users. We're taking it to a place where it's much, much more easier to run with eager execution. And no more compiling a graph and then running it. There's still the option to do it if you want it. We're simplifying, we're removing some of the APIs into Keras. You'll be defining your architecture using layers in Keras, but the logics will still remain the way you used to in TensorFlow. Estimators, great things. We've added them a way back. Now we've added distributed strategy. Today, if you wanted to train on a cluster, so the way to kind of differentiate how everything goes everywhere is kind of complex. You can go and you can do all ring reduce on your own, or a number of other schemes. With distributed strategy, all you have to do is choose a strategy, and we'll take care of the rest for that, and some other things that I recommend you go check. What is Google's vision? Why am I here? Why am I talking to you? I will briefly cover a number of the tools. We want to help you actually reach AI, reach the capability of AI in production. This is a graph from 2008 to 2017 of some Fortune 500 companies and their earnings call. We see that machine learning and AI is being mentioned more and more, and we want to help you do that. we're looking at statistics and we're working with customers, and a lot of the times we hear things like we want to do a feasibility study, we want to get our hands dirty with machine learning, we want to start collecting data, proof of concept, we want to maybe do a pilot to integrate some kind of machine learning capability. But the fact of the matter is that less than 12% of enterprise companies actually have a machine learning in production, and this is according to Gartner. Part of the reason is the actual skill set, and we're also doing some stuff to help there with some mock courses and some trainings. We have kind of a skewed ratio between ML experts and actually business users who could benefit from machine learning models. Our strategy is built on top of three things: solution, building blocks, and platform. Let's dive right into it. First tool that we released, and this can kind of help you maybe enrich your data or actually get started on a project, is a dataset search. You can search, you can get a dataset, it's pretty straightforward, and it can shorten the time. We have three main ways to do machine learning on top of Google. The first one is kind of you choose everything from top to bottom. You take a computer, whether it's on top of Kubernetes, whether it's on top of compute engine, or whether you're using a completely serverless cloud machine learning engine. You write the code, you define everything, you write the pipeline, you augment the data. We simply give you the tools to run everything in an efficient, both in cost and performance way. The second one is maybe the one on the right. It's out-of-the-box APIs. And the third one is AutoML. I'm now going to discuss the second two. So the ML APIs are basically network requests, which give you a response according to which one you use, everything that we know about the data that you've given us. An example to that could be the Vision API. You send us a network request with a picture, and we tell you the number of things that we know about the picture. This model is continually improving, both in terms of performance, which is right now state-of-the-art, best in the market, I believe, and in terms of feature set. So these are just some of the features that you can do with it. Another example for out-of-the-box API, which you could be using, is Speech API. Give us a file, and we'll actually tell you who's talking, what is he saying, and it works in a number of different languages, and is, again, state-of-the-art. The second option, which is actually the more interesting option, since I believe that most of you are somewhat familiar with the first option, is AutoML, which is a service right now that is unique to Google. What is AutoML? First of all, AutoML requires very little expertise, and I'm going to show you actually how the wizard looks and how long it takes. It requires very little data, which is sometimes a blocker for you getting started. A lot of the times customers will want to do a machine learning project, and it starts with a year of either converting data or collecting data or augmenting data. It's a long step. And the third one is it gives you a model which is domain specific to you. I'm going to give an example. What is AutoML in the background? It's based on three things. The first one is the learn-to-learn paper, which is a neural architecture search. The second one is transfer learning, where we bring a model and we only retrain a small part of it to answer, again, your domain-specific answer. And the third is hyperparameter tuning. The basic point here is that you bring a very minimal data set. You don't have to know how to write any code, and we actually use these three capabilities in order to train something that is domain specific to you. So say that you are, I don't know, you're working with airports and you want to identify which type of plane just came in to port. You might use the Vision API, you would make a request, you would get back. In most chances, you would get back that it's a plane. We might even know to tell you a thing or two about the plane, but I'm assuming since this is very domain specific, we wouldn't know to tell you exactly which plane it is. Or even if we didn't know it was a 747, we might not know to tell you which type, nuance. With AutoML, you could bring a relatively small data set of planes, of the different things that you would like to identify, and in less than an hour's of work, and the model itself can take anywhere between 13 minutes to train to however you'd like it. I say 13 minutes because every time I've demoed it, it's taken about between 10 to 15 minutes. And it's outperforming a lot of what we see out there. So even if you are using ML in production and you're writing your own models, if you believe that your machine learning model is state of the art, my recommendation is always to benchmark, to try this. If you're using a classification problem when it comes to vision or any of the other AutoML solutions that we've released as of late, you should at least benchmark it and see how well your model performs. Worst case, you've wasted a couple of hours. Best case, you actually have a new model that you can download and use anywhere that you like. How does it look? So again, like I mentioned, you take pictures, they're labeled, you give them to the engine, it does its own stuff, you can cap how many hours exactly it's going to be training, and at the end you get a model that deciphers exactly what the question that you're looking to answer. A bit about the wizard. So it's really, really simple. It's a wizard. Okay, it's comprised of 3 main steps. First of all, you define your data set. Second of all, you make sure that the labels are actually correct. Then you train. Like I said, you can cap how long the model is going to train. And normally I would recommend that the first one would be just a couple of minutes to maybe an hour to see how well it performs in the initial problem. And then you can evaluate and rinse and repeat. Okay, another tool that we've released, this is not new, this is actually, I believe we listed close to 2 years ago. Tensorflow Hub, this is simply a library with reusable models. So as you can see here on the right, in code, I imported. What is a model? A model is actually an independent part of a graph, and you can take it. It can be anything between a mini part of the architecture, all the way down to embeddings, and this can get you started really easily. If you would like to perform, just say, transfer learning, which is relatively easy to do on your own, and it's the second step I showed within AutoML, you can import a model which is relevant to the problem that you're trying to solve, and just continue from there. Now, I have a whole lecture about this, and this is actually a lot of what I do on my day-to-day job, is help people build architectures end-to-end. We understand that machine learning is not simply, writing the state-of-the-art TensorFlow code. Yes, a lot of the times it's important, but it's comprised of much more. Like I said before, you need to go collect the data, you need to store it, you need to actually do some exploration to figure out what's relevant, what's not relevant, clean the data. We have a lot of toolings all around, not simply in the training part, though I think the training part is most interesting. So how do we go from here to here in a quick manner? There are a lot of ways, there are a lot of tools. I think I've covered a few which are interesting, and this is really a game changer in my opinion, and I will explain what it is. So AI Hub is this one place. You can think of it sort of as a marketplace where you can discover, use, and share different ML models or components or modules, as I explained before, amongst other things. What is the mission? The mission is to have this one place for you to do everything AI, both exploring, finding, using, sharing, and how does it look? So basically, it's a catalog, and it's a one-stop AI catalog. It has enterprise-grade sharing tools, which means you can curate your own solutions, and you can also share solutions with people within the organization, and it's easy to deploy. Okay, what do I mean when I say easy to deploy? It's based on Kubeflow. Kubeflow is built on top of Kubernetes, and it's really packaging that helps you, package manager, which helps you really get started easily on top of Kubernetes. It has a lot of stuff, but basically you can think about it, whoever hasn't used it, you set up a cluster. If you're using GKE, which is our managed offering, it's already GPU ready, and you can simply install whatever components, such as TensorFlow, XGBoost, scikit-learn, and get started. Recently, we are working on Kubeflow pipelines, which it's a bit hard to see, but it will orchestrate the whole process. So it's, like I said, not only the training, but every component. You have here pre-process, feature transformation, then you can actually have the different trainings. It can also be dynamic. You can choose things like XGBoost model or train a different CNN and model validation, and all the way up to push to serving. So very similar to, if some of you watched TensorFlow to the last Dev Summit, very similar to TFX. And the idea here is that this is an end-to-end pipeline, which you can then curate within AI Hub as a whole or as different components. So if somebody within the organization is working on a problem which you might have solved part of, he can then go, take this module, and presumably he doesn't have to do one of the steps. This is a bit how it would look like in code. Basically, the idea here is to show that it's relatively easy to get started. This is not the only thing that would be within AI Hub. We plan to include many, if not all of our tools within it. And this is the idea of how you would share. You would have both the public content, which will be obviously tools from Google, and third-party contributions. And you will have your own private curated content which people within your organization could leverage, amongst other things. So BigQuery ML, just a few words and I'll wrap up with my lecture. So BigQuery, for anybody who's not yet aware, it's a petabyte scale data warehouse and analytics engine. Very, very powerful, can handle huge amounts of data. And I'm just going to talk about briefly, 30 more seconds. BigQuery, we've recently added the ability to do ML models within SQL. Huge power. You have to have a really minimal skill set. This is already your data warehouse. And in SQL, you can actually define the model that you're going to run. And we've had C-level CFOs, CEOs use this on the data over a weekend with little to no expertise and get insights. Great. Last but not least, TPUs, which is our custom hardware for building ML models. If you would take two things away from what are TPUs, so they're state-of-the-art training, they give you excellent performance, and they scale really well. We're currently at version 3, which gives you 420 teraflops per training. And I'd like to thank you all, and enjoy the rest of the convention.